Hi class, in this section we're going to be talking about 4.1, divisibility. And so really our objectives are just to kind of get an idea of what we mean when we say divisibility, what a factor is, and what a multiple is. And so once we discuss what divisibility is, we're going to talk about divisibility tests, or way we see if a number is divisible by 2, 3, 4, 5, 6, 8, 9, 10, and 11. And so it's also important, and we'll get to this maybe less in this video, but a little bit more in a future video, that the number of factors of a number is finite and the number of multiples of a number is infinite. So, starting with a definition for even. So a number is even if it has remainder of 0 when divided by 2. So if we have a number like 14, and we divide that by 2, and we get 7, we can say that 14, because there's a remainder of 0, is even. But if we have 21, we divide that by 2, we get 10 with a remainder of 1. We call those numbers odd. And so that's how we distinguish between even and odd. Even means divisible by 2, and odd does not. And so we have this little symbol that you maybe haven't seen before, the vertical line, which means divides. So we can say that 3 divides 18, which is written as 3 divides 18, because the remainder is 0 when 18 is divided by 3. So relatedly, we could say that 2 divides 14, or we could say that 2 doesn't divide 21. But 3 divides 21, and 7 divides 21, right? And so that's using those numbers from the previous slide. So just any general B divides A. And so we read that as B divides A. And so unlike division, so like D divided by B, which is talking about an operation, this is talking about a relationship. And so here's just a prettier version of 3 does not divide by 25. Written 3 does not divide 25 because the remainder isn't 0. What is it? It's remainder 1. So if we know that something divides something else, we can call it a divisor. So this says for any whole numbers a and b with b non-zero, if b divides a, that's the same as saying there's some q such that a is b times q. So let's look at our example. 2 divides 7. Well, that means that there has to be some q such, or 2 doesn't divide 7. 2 does not divide 7. I got ahead of myself because you're going to see why as soon as I say it. 2 divides 14 because there's got to be some number q such that 14 equals 2 times it. And what is that it? Well, that it is 7. So all that's saying is if b divides a, then we can write it as a equals b times some number. And then we call both of those numbers b and q are factors or divisors. So 2 and 7 are factors or divisors of a, or 14. So 2 and 7 are factors of 14. And then we can also say if a is a multiple of b, so 14 is a multiple of 2 and 7. So just giving us words to relate when a number divides another, what is a factor or divisor, and which one's a multiple. So some examples. Is this true? Are these true. 3 divide 12. Well, if it does, there should be no remainder. When we divide by 3, we get 4, remainder 0. And so that one is true. 0, does 0 divide 2? Well, let's use our equivalent thing. So it said if 0 divides 2, there's some number such that 2 equals 0 times something. Is there anything we can put into that blank to get us 2? And the answer is no. So this one is false. Is 0 even? Well, 0 means if we divide by 2, we get 0, remainder 0. 0 is even. Is it true that 8 doesn't divide 2? If so, and you have to remember we're not working with fractions yet, we're still working with our whole numbers. So is there a number such that 2 equals 8 times a whole number? No. So that is also true. So true and true. And now I'm regretting how I have the slide set up. Because for all whole numbers A, does 1 divide it? The answer for that one is yes. And why is that? Well, let's look. 1 divides A is the same as saying A equals 1 times some number. And for every A, if you just put A there, you get A. And so that is also true. And the last one, for all non-zero whole numbers, and I'll erase it because we can't see that. For all non-zero whole numbers A squared divides A to the 5th. Well, is that true? Well, A squared divides A to the 5th means we get A to the 5th equals A squared times something. And is there a something? Yes, A cubed. That is also true. So we had true, false, true, 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 and true. Here it says, is it true that 3 divides 6n for all integers? If so, that means that 6n equals 3 times something. Well, if I put a 2n in there, 2 times 3 is 6, and we have an n in both places, and so that is true. So I think when we're working with divides, it's important that we either, and I'll write this over here, we either want to divide and show remainder 0, or find q such that a equals b times q. So some properties of division. So for any whole numbers a and b, if d divides a, then d divides n times a. So in other words, if d is a factor, then d is a factor of any multiple. So let's look at an example. Is it true that 3 divides 6? Well, 6 divided by 3, 2, remainder 0. So 3 does divide 6. And then let's look at some whole numbers. Let's say n equals 2, n equals 7, and n equals 9. Well, if n equals 2, is it true that 3 divides, and I'll put a little question mark above it, does 3 divide 6 times 2 or 12? It does. Because when we divide that, 12 divided by 3, get 4, remainder 0. Or for n equals 7, is it true that 3 divides 7 times 6. Well, we can use our equivalent form. Is it true that 7 times 6 equals 3 times something? Well, 6 is 2 times 3. So if I have 3 times 7 times 2, it does. And we can see the same with 9. But we can also just work on that directly. And so we have 9 times 6 is what? 54. 54 divided by 3, and that's what, 8? No, it's not at all. That's not even close to 8. If we multiply this out, 54 divided by 3 goes in, there's 1, 30, 24, how about 18? There we go. Almost, I had the 8 right. Okay, so divides is an important relationship to have between numbers, and if a number divides another, it will divide any multiple of it. Another property for any whole numbers a, b, and a whole number d, as long as d isn't 0, if d divides a and d divides b, then d divides a plus b. For example, suppose we have, do you agree that 2 divides 6 and 2 divides 10? This says if 2 divides 6 and 2 divides 10, then 2 divides 6 plus 10, which is what? 18. And so if we 18 divide by 2, 9, remainder 0. That is true. So if a number divides a number, if one number divides another, it divides a multiple of it. If one number divides two numbers, it divides their sum. And similarly, if it divides only one of them, it won't divide their sum. For example, if 2 divides 6, but 2 doesn't divide 7, that's a rough 7. Let me erase that. 2 doesn't divide 7, then 2 should not divide 6 plus 7. Or 2 doesn't divide 13, which is true because 13 divided by 2 is 6, remainder 1. And if it doesn't divide the second one, similarly, let me erase that so you can see it. And so this is similar to part A. If it divides their sum, it also divides their difference. So, looking at a specific example, 2 divides 6 and 2 divides 10. And remember, subtraction is only defined for the larger number minus the smaller. So, if 2 divides 10 and 2 divides 6, then 2 divides 10 minus 6, or 2 divides 4. So we have divides works for sums of numbers and divides works for subtractions. And then this one is our analog to number B. If it only divides one of them but not the other, then it doesn't divide their subtraction. So just like if we had 2 divides 6, 2 doesn't divide 7, 2 doesn't divide their difference, or 1. And we have the same one. If it doesn't divide the smaller number, then it also doesn't work. So if you had 12 minus 7, the difference is 5, and they do not divide. So examples. Classify each of the following as true or false for any whole number x, y, and z. It says if 3 divides x and 3 divides y, then 3 divides xy. Well, I'm going to bring that up here. 3 divides x means x equals 3 times some q. And if 3 divides y, means y equals 3 times some, I'll call that q1 and this q2. Well, that means x times y equals 3q1, 3q2, and xy is 3 times 3q1, q2. But because xy equals 3 times something, we can use our definition of divides and go backwards, and that says that 3 does divide xy. That's a little square because this really what we did here is a proof. And so my instinct was just to go ahead and put that little black square, which is how most mathematicians add it. So maybe take a second and pause the video here and see about if 3 divides x plus y, then it divides each of them separately. Or if 9 doesn't divide it, then 3 doesn't divide it. Think about that, and then I will be right back. All right, so if you had a chance to look at that, you would see that it's not always true that if 3 divides their sum, then it divides their product. Let's look at a simple case. 3 divides 1 plus 2. 3 divides 3, but 3 doesn't divide 1, and 3 doesn't divide 2. Also, for 9 not dividing a, then 3 doesn't divide it. Well, consider the example of 6. A equals 6. Well, 9 doesn't divide 6, but 3 divides 6. So it's not true that if one of them, if a number doesn't divide it, that they necessarily won't divide otherwise. Let me say that a little more clearly. If a larger number doesn't divide a number, then it's not necessarily true that a smaller number doesn't divide it, right? So if 9 doesn't divide 6, 3 still divides it, and we can't say that because it's smaller. But it's not always that either, because 9, and we're going to talk about prime factors in a couple lessons, but 9 is 3 squared, and 6 is 2 times 3. And so just because there aren't 2 3's in it doesn't mean that there isn't still 1, right? And so that's an important distinction to make there. So we now have talked about what divisibility is and kind of the equivalent way to think about it. So like if A divides B, that's the same as saying B is A times some Q, right? That there exists some other number Q that divides it. Well, just in existing in the world, we often just want to know if something is divisible by another number just by looking at it. And so we had some rules. We said that if A divides B and A divides C, then it was true that A divides B plus C, right? If it divides 2 numbers and we add them, it still divides. So here it says if we want to check if 1734, so 1734, is divisible by 17, we can rewrite 1374 as 1734 as 1700 plus 34. Well, 1700 is just 17 times 100, and 34 is just 2 times 17. And since 34 has a 17 and 1700 has a 17, we know that 17 divides 1734. And so that's one way we can work about it. But we maybe don't often care if a number is divisible by 17. I mean, unless you have 17 students in a class. But we more often care if, say, a number is divisible by 2, if it's divisible by 5, or if it's divisible by 10. And so a number is divisible by 2 if and only if. So that's divisible by 2 if the units digit is divisible by 2. And you might say, well, why do we only care about the units digit? Suppose we have 324. Why do we know that that's automatically divisible by 2 just because 2 divides 4? And why isn't it that, say, 327 isn't even because 2 doesn't divide 7? Well, let's think about place value. 327 is 3 times 100 plus 2 times 10 plus 7. And actually, instead of starting with the 7, let's start with 324. So I can rewrite this 100 as 2 times 50 times 3, plus this 10 as 2 times 5 times 2, right? So there's the 10. And that 100, I guess, fix my lines. Well, we know that 2 divides this piece, and 2 divides this piece. The only piece we need to check is this here, and that's not a 2, that's a 4. So that's the same with 327. Because the hundreds is, since 2 divides 100, 2 divides 300. And since 2 divides 10, 2 divides 20. And so we only need to check the units digit because the tens, hundreds, thousands, and so on will always be divisible by 2. And now that same argument holds here for 5, because, let me pick a different color. The 10 has a 5 in it. The 100 has a 5. 1,000 will have a 5, and so on and so on. So all we need to check is this last digit. And if we're looking at divisible by 10, well, let me pick a third color. Oh, I already used blue. There's a 10 here. There's a 10 inside that 100. And so we just need that 10 divides the units digit. Well, the only unit digit that 10 can divide is 0. And so that's why we have divisible by 2 if the units digit is divisible by 2, divisible by 5 if the units digit is divisible by 5, so that's 0 or 5, and divisible by 10 if the units digit is 0. And so we have 2 other divisibility tests for these powers of 2. We have our 4, which is 2 squared, and 8, which is 2 cubed. And it says a whole number is divisible by 4 if and only if the last 2 digits are divisible by 4. So divisible by 4 if and only if the last 2 digits are divisible by 4. Well, I'm going to write just a general number. 1000A plus 100B plus 10C plus D. So this is some 4-digit number. Pick your favorite A, B, C, and D. It could be 4,327. If I write, and so I'm going to pick 2 different colors. Blue is going to be the divisible by 4 case. Well, 1,000 is 4 times 250, plus 100 is 4 times 25, plus there's not a 10 in, or a 4 in 10, and we don't know if there's a 4 in that. So 4 will divide this. Well, it divides that, only if and only if it divides those last 2 digits, 10C plus D. And a similar argument can be made for divisible by 8, if and only if the last 3 digits are divisible by 8. Because if I look at 8 divided by, and so there must be an 8 in 1,000, and I think our answer is 125. 8 divided, we have 8 times 125, A plus 100, B plus 10, C plus D. Well, since we know that there's an 8 here, that's divisible by 8, and all we need to check is this 100B plus 10C plus D. And those are precisely our last 3 digits. So if we're looking at 2, 5, and 10, we only need to look at the last digit, because every place value higher than the ones, tens, hundreds, thousands, and so on, is divisible by 2, 5, and 10. Now if we're looking at 4 and 8, because in the case of 4, hundreds, thousands, and so on is divisible by 4, we have to check the last 2 digits. But because the 1,000 is the first digit that is divisible by 8 guaranteed by place value, we have to check the last 3 digits. And so here it says determine whether whether this number, 97,128, is divisible by 2, 4, and 8. Well, does 2 divide it? 97128. Well, it does if 2 divides 8, and it does. 4 divides 97128, if and only if 4 divides 28. So 4 times 5 is 20, plus 8, it divides 20, divides 8, so it does. So it divides by 2, divisible by 2, divisible by 4, and then 8 divided by 1, 28. So let's see, that is, does 8 divide 80 plus 48, right? That's 128. Oh, it divides 80, and 6 times 8 is 48. So this 97,128 is divisible by 2, 4, and 8. Now it says determine whether 83,026 is divisible by 2, 4, and 8. Well, we know it's divisible by 2 because 2 divides 6. Does 4 divide 26? 6 times 4 is 24, 25, 26, 27, 28. 7 4s are 28. It does not divide. So yes, no, and then 8. 0, 2, 6. Does 8 divide that? 8, 16, 24. It does not. And there we go. So there's some working with divisibility. Now, I'm not going to show you why these ones work, and part of that reason is because it's going to use something called modular arithmetic, which we haven't covered. But I do want you to know that a number is divisible by 3 if and only if the sum of its digits is divisible by 3. And a number is divisible 9 if and only if the sum of its digits is divisible by 9. So let's look at an example. This says determine whether 1002, 1002 is divisible by 3 and 9. We have 1 plus 0 plus 0 plus 2 is 3. Well, 3 divides 3, so it is divisible by 3. But 9 doesn't divide 3, so it's not divisible by 3. And then determining whether 14,238 is divisible by 3 and 9, we take 1 plus 4 plus 2 plus 3 plus 8. We get 1 and 4 is 5, 6, 7, 8, 9, 10, 18. Well, 3 divides 18 because it's 3 times 6. And 9 divides 18 because it's 2 times 9. So it's both divisible by 3 and 9. Now this is a slightly more interesting example. It says a store manager has an invoice for 72 calculators. That's a lot of calculators, but anyhow, he's a store manager, so he's probably selling them. Maybe selling them to pre-calc students. The first and the last digits of the receipt are illegible, so he can't read those first 2 digits, but he needs them. He needs them to put into his book, because apparently he lost his email, or this was before they had email and he only had a paper receipt. The manager can read 6 something, 67, and 90 some cents. What are the missing digits? and what was the cost of each calculator. So note there are two parts. First, we need to know missing digits, and second, cost of each calculator. So let me give myself some more work. Well, we know that 72 needs to divide something 67.9 something. And we can also look at 72 as 9 times 8. Because 8 times 10 is 80, take 1 away, 72. And so we know that this number, something 67.9 blank, needs to be divisible by 8 and by 9. Well, if you remember our divisibility test for 8, it wasn't that the last digit or the last two, but the last 3 digits had to be divisible by 8. So we need that 8 divides 7.9 blank. And so we can go ahead and look at 790 isn't divisible by 8. How about 790? Do we even need to check 791? $791 divided by 8. 792 divided by 8. 792 divided by 8 is 99. So we know that last digit has to be 2. Because the next one that would be divisible would be 8 more than that, which would be 800 even. And so we know this last digit is a 2. And now it needs to be divisible by 9. And so we know that whatever this first digit is, so blank, plus 6, plus 7, plus 9, plus 2, that 9 needs to divide that. Well, that means 9 needs to divide. 6 and 7 is 13, plus 9 is 22, 23, 24. 9 needs to divide something plus 24. So 9, 18, 27, it could be a 3. 36, well, it can't be a 12. So that has to be a 3. So that means that the 72 calculators cost $367.92. And now remember the second part of the question was how much did each cost? Well, $367.92. 367.92 divided by 72 calculators is $5.11 each. So the total was $367.92, and they were $5.11 each. And so 2 more divisibility tests that I just want you to know there are. The 6th one, slightly more useful. So a number is divisible by 6 if and only if it's divisible by 2 and 3. So it needs to be even, and digits, sum, divisible by 3. Let me go ahead and look at it. Oh, I don't have a good example there. So what's something that's divisible by 6? 96. Is it true that 6 is divisible by 96? Well, we check, does 2 divide it? And does 3 divide it? Well, that last digit is even, so 2 divides it. And 96, 9 plus 6 is 15. 1 plus 5 is 6. And 3 divides 6, so it's divisible by both. And 96 is divisible by 6. And let me go ahead and give us a different number. 704 is 704 divisible by 11. And actually, I want a bigger number than that. 11 times. We'll look at 704 first. So our divisibility test is we take our alternating sum. So we have 4 with a plus sign, 0 with a minus sign, and 7 with a plus sign. 7 minus 0 is 7, plus 4 is 11. And since 11 divides 11, this number is divisible by 11. Is 5,236 divisible by 11? Well, we have plus 6. That 6 is hard to see. Minus 3, plus 2, minus 5. And so that's what I mean by alternating sum. We have plus, minus, starting from the right. So we have negative 5, plus 2 is negative 3, minus 3 is negative 6, plus 6 is 0. Does 11 divide 0? Yes, remember we said that every number divides 0, because this is just asking 0 equals 11 times something, and that something is 0. So that number is divisible by 11. And so now we'll go ahead and put it all together. Determine whether 57,729,000, no, I was off by it, 57,729,364,583 is divisible by each of the following. Is it divisible by 2? Well, 2 doesn't divide 3, that last digit. So it is not divisible by 2. Unfortunately, run out of colors. But now we need to know if it's divisible by 3. So we need to take the sum, 5 plus 7 plus 7 plus 2 plus 9 plus 3 plus 6 plus 4 plus 5 plus 8 plus 3. So we have 5 and 7 is 12, 19, 21, 30, 33, 39, 43, 48, 56, 59. And 5 plus 9 is 14, and 1 plus 4 is 5, and 3 doesn't divide 5, so it's not divisible by 3, right? And so we can't just look at that last digit and see, well, that's a 3, so maybe our hunch, our instinct is that it's divisible by 3, but it turns out that it's not divisible by 3. And then our next one, is it divisible by 5? Well, remember our divisibility test for 5 is if our last digit is 5. Well, the last digit isn't 5, so it's not divisible by 5. And then the next one says, is it divisible by 6? Well, remember our divisibility test for 6 is we need both divisible by 2 and divisible by 3. Well, we already said it wasn't divisible by 2 and it wasn't divisible by 3. So it can't be divisible by 6. Dang, this number doesn't have any divisors, it seems. 8. Is it divisible by 8? Well, so here we need not the last digit, not the last 2, but does 8 divide 583? Well, we can look at it. We can we could break it down and see. But unfortunately, it does not. So, divisible by 9. If it's not divisible by 3, can it be divisible by 9? Well, we already had its sum. 1 plus 4 was 5. Does 9 divide 5? No. It's not divisible by 9. 10, is the last digit 0? No, it's not. And now 11. And so what I'm going to do is I'm going to switch to a different color. And I'm going to change my sum to an alternating sum. So I had plus 3 minus 8, plus 5 minus 4, plus 6 minus 3, plus 9 minus 2, plus 7 minus 7, plus 5. And so now I have 5 minus 7 is negative 2, plus 7 is 5, minus 2 is 3, plus 9 is 12, minus 3 is 9, plus 6 is 15, minus 4 is 11, plus 5 is 16, minus 8 is 8, plus 3 is 11. So does 11 divide 11? It sure does. And so this big old number here is divisible by 11. And let's see if I can type this whole thing into my calculator. 57,729,364,583 divided by 11 is in fact, so this number equals 11 times 524812405 That's a long number. And so I just want to wrap this up. We talked about the meaning of divisibility, right? A divide B is the same as saying B can be written as A times a number. That number can be 0, it can be anything. If A divides B and A divides C, then we know that A divides B plus C. We have sums. If A divides B, then A divides some multiple of B. So B times any number will be divisible by A. And then we can check for 2, the last digit. 4, last 2 digits. 8, last 3 digits. 3, sum of digits. 2, 3, 4, 5, last digit. 6, 2, and 3. 7, we don't have a nice neat rule. 8, last 3 digits. 9 is also sum of digits. 10, last digit. And 11, alternating sum. And that's right to left. And that covers all we need to know about divisibility.